In this video, I'd like to talk about the concept of compound inequalities. So with these inequalities, you're going to be given two separate inequalities and then either an or statement or an and statement. So the general strategy for solving these inequalities is to solve both of these inequalities at the same time. And then what I'll do next is put them both on a number line and essentially just figure out where they overlap. Because for an or statement, the points on the number line that satisfy at least one of these would be the answer. But for an and statement, the points on the number line that satisfy both inequalities would be the answer. So I'll formalize that as we go. I'll write it down, but let me just give you an example of how we would solve a problem, and then we can kind of talk about the bigger picture. So the first step is just to solve each of these inequalities by themselves. So we have 12x plus 7 is less than minus 11. And over here, I'll write 5x minus 8 is bigger than 40. So we're going to solve both of these. So we're solving for x. We're going to treat these pretty much just like equations. The only difference is that if we multiply or divide by a negative number, we have to remember to flip the sign. So for this first inequality, we want to get rid of the simpler operations first, the addition and subtraction, because we want to isolate our x term on one side. So I have to get rid of this plus 7, and I can do that by subtracting 7. So I get 12x plus 7 minus 7, that's just 0, is less than minus 11, and then minus 7 more will bring us to minus 18. And then from here, we can divide each side by 12 to cancel out that multiplication. 12 divided by 12 is just 1, so you get 1x or x. And 18 and 12 are both divisible by 6. So I'll divide them each by 6 to simplify this fraction, and you get minus 3 halves. So that is one of our inequalities, but now we have to solve the other one. So for this one, we want to, again, isolate the x term, so get rid of the minus 8. We will add 8 on each side. These cancel. And you get that 5x is bigger than 48. And from here, I'll just divide each side by 5, cancel out that multiplication. So you get that x is bigger than 48 over 5. And if you want, you can put this as a decimal or a mixed number. In fact, it might be helpful when looking at the number line. So 5 goes into 45 9 times, and there were 3 left over. So you could write it 9 3/5 or 9.6, however you want to do it. So let me just box this one in as well. So for this compound inequality, we have this or statement. And let me write this down. So anytime you see or, it simply means satisfies at least one inequality. So let me actually just write that in. So satisfies at least one of the inequalities. And what we're going to do next is just mark each of these essentially ranges of values on the number line. Because to satisfy this one, x has to be bigger than 9.6. So if values are bigger than 9.6, then we can say that they at least satisfy this one, and that would be valid. And then over here, looking at our other inequality, if there are values less than minus 3 halves, which by the way is just minus 1.5, if they're less than this, then they would satisfy this inequality. So let's draw our number line here. Let me just get a line going. And with this line, I usually like to mark 0 just as a reference point. So let's say that's 0, and we'll count by 2. So 2, 4, that's a 6, and then 8, 10, and 12. And going the other way, we got minus 2, minus 4, and so on. And I'm going to mark this one first. So x has to be less than minus 3 halves, which we know is minus 1.5. So that's going to be somewhere probably right here. And what I'm going to do is use an open circle because we don't want to include this point at minus 3 halves because it has to be less than that, but we didn't have less than or equal. So we're going to use an open circle. If you had less than or equal, then you would fill in the circle. But we don't have that, so we'll leave it open. And then it's all x values less than minus 1.5. So we'll draw the arrow in the direction of the values that actually satisfy the inequality. So that's this one. And then over here, we have x is bigger than 9.6, which is probably somewhere around here. And again, it's an open circle because we don't actually include this value of 48/5 since we didn't have greater than or equal to. And we want to draw the arrow to the right because all values bigger than 9.6 would satisfy this inequality. So a value like 10, 11, 12, and so on, they all satisfy this one. A value like -4, -6, -8, they all satisfy this one. But values like 0, 2, 3, and so on, all of these in the middle here, these do not satisfy either of them. So if we had an AND statement, that would mean that our values would have to be part of both intervals. And so if it was an AND statement, then there would actually be no solution. That would be D here, because it has to satisfy both, and you can't have a number in both of these arrows. Now, if this one was drawn backwards, then values over here would work to satisfy both. But since it was drawn in the other direction, if this was an AND statement, you would get no solutions. Now, because it's an OR statement, it just has to solve at least one of them. So a value like 10 would satisfy this inequality, even though it doesn't satisfy this one. And that's okay, because we just need it to satisfy one of them. So everything bigger than 9.6, so all of these values over here satisfy this inequality. They satisfy at least this one, even though they don't satisfy this one. And again, over here, values less than -1.5, so -2, -3, -4, -5, and so on, they all satisfy this one, even though they don't satisfy this one. So OR statements just mean that as long as your value is in at least one of these intervals, then it's part of your solution set. So for our answer here, we want all values less than -3.5, and we also want all values bigger than 9.6. So that's going to be this one, choice letter A here. Since notice this part covers this solution set, and this part covers this solution set. And since it's an OR statement, as long as it satisfies one of these, then it's okay.